this is Unit 2, Lesson 6, the Bunsen burner lab and melting ice. The first thing we need to go over is all the parts of the Bunsen burner. Now, be careful today because you can burn yourself pretty bad if you're not careful. This is a Bunsen burner setup right here, and you have the gas inlet. The gas inlet's right here. It is connected to a hose. The hose connects to your Bunsen burner, and that's what provides gas to it. So the gas goes into this part of the base down here. It's called the gas chamber. And this is the needle valve. If you will look, it's kind of sharp on the end, looks like a needle. There is a machined place in the gas chamber on the other end, and it will go in there and seat against it, and it will close off and stop the flow of gas into the Bunsen burner. On the other end of the needle valve, there is a ring right up here. It's called the O-ring. The O-ring is a rubber O-ring, and it stops gas from flowing out the other side or leaking out the other side of the Bunsen burner. Now, do you guys remember when the space shuttle went up and it exploded? Any of you remember what happened or what caused that?
It happened in 86.
Yeah, you guys weren't around then, but anyway, they sent the space shuttle up, and on the big part of the rocket boosters, you know, you got these great big tanks full of rocket fuel, and then the shuttle sits up there on it. These parts will come off. When it runs out of fuel, they'll drop that off to take the weight off, so it's easier to get the thing into space. These O-rings keep that fuel from leaking out. One of the engineers told them, if that O-ring, if you fire that thing and it's under like 38 degrees, that O-ring could fail or leak. Why do you think that would be? Why would temperature be an important thing with and these O-rings they're huge. I mean, they're huge. What do you think could happen? Well, the telephone wires that are out front, you see how they've got a little slack in them? They hang down a little bit like this. Okay? What happens when it starts getting cold around freezing? Do those things get longer or shorter? Shorter. How come? When the rubber contracts, it gets smaller. And most everything gets smaller when it gets colder. Can you think of a substance that gets larger when it gets colder? Ice or water. Yeah, and we'll talk about that later on. But what happens is that O-ring gets small enough that jet fuel can leak out, and it did, and it ignited, and it blew up the space shuttle. We lost 8 astronauts, including Krista McAuliffe. Union named an elementary school after her, the McAuliffe Elementary. So anyway, she was a teacher, and she got to go up in the space shuttle and all that. All right, but this is the needle valve with the O-ring. It does the same thing in here. It keeps the gas from coming out this end. Now, this is the gas jet. It's in the very top of the base, and it has a very small hole in it, a very small. That's called an orifice, or an opening. It allows the natural gas from your tables to go up into the Bunsen burner, into the barrel. It then ignites, it mixes air and gas, and then it ignites up here and it produces a flame. This orifice is different size for different sizes of gases. Different gases have different molecular makeups, and this will not work for like propane. The gas that goes to your house is the same as the gas that goes to these tables. But the propane, you know, you have the big tank that you go get for your barbecuer. That is propane gas, and it has to have a different size jet or a different size orifice. If we drilled this out bigger, it would actually work. Okay, so that is the gas jet with an orifice in it. That's number 4. 5 is the base, this big part down here. We then have the barrel. This barrel is what mixes the gas and the oxygen, the air together On that, you have slots. And these slots are what allow the air to get into the barrel. This collar also has slots in it. When you close the slots, it allows the flame to burn at a lower temperature. It will be orange. Sometimes I've cleaned these up so they burn pretty good. It'll be kind of blue, but the more orange the flame is, the cooler it is. When you open this up and those slots start to get larger, does that increase the amount of air that gets into the flame? What happens to the flame when you increase oxygen to it? Does it get hotter or colder? Gets hotter. How can you tell it's hotter? Turns more blue. It's more blue. Now, if you keep opening this up and those slots get to the point that there's too much oxygen, it will blow out your flame. When that happens, the gas is still going into the Bunsen burner. What should you do at that point? Immediately.
Turn off the gas.
Turn the gas off. How do you turn it off? You can use the needle valve, but these are old enough that it won't completely seal. If you will turn it off with the hand valve at your table, that's the best thing to do. Anytime you have any question about anything, turn it off there. Okay? We get a flame going. The flame is going to come up and it will have a little tip that's about right there. Set your ring stand, this is a ring stand and wire gauze, about the width of your hand above the top of the Bunsen burner. Okay? Light it. Then you are going to get 100 milliliters of water up to this line from the tap, and that'll be tap temperature. You'll then use this LabQuest, and you will take the temperature of the water. Okay? You're going to take it in Celsius. Then to change it, you tap the screen, and it'll say change the units. You change the units. Come on now. And down here it says Fahrenheit. You also want to do it in Fahrenheit. So it was 20-something, and now it's 72 degrees Fahrenheit. That's the room temperature right now. Okay? So take both of those. You are going to then put the water on here and time it. As soon as you put it on there, time it. You've got a stopwatch if you need it. Your phones have a better stopwatch than this one. You get it going until it's boiling, and not when just one little bubble comes up, but when it gets going pretty good. When that happens, kill the flame. Put your probe in here. Take your water temperature, okay, in Celsius, in Fahrenheit. Then take the tongs. Do not grab this, it will brand you. Pick it up with the tongs. Tongs about halfway up on the beaker. Pour this into your sink. Should you run water over this after? How come? You should not, because it will crack or break. Okay, just set it on your countertop and let it cool. You then, before you start this whole thing, go up and get ice up to the 100 milliliter mark. Okay, don't go higher, don't go lower. Get it where it is this level. Then fill it up with water to there and let it sit for the few minutes while this is boiling. Then you're going to run the experiment with ice water.